Water is one of the most important natural resources. It is necessary for every industry, such as agriculture, energy production, and recreation, to name a few. However, these industries and other human activities interfere with the purity of natural waters through runoff and direct source pollution. I'm interested in one class of contaminants called endocrine disrupting chemicals, or EDCs. These chemicals interfere with an organism's endocrine or hormone system. For example, ethinyl estradiol is an EDC. It's the active ingredient in most oral contraceptive pills. The EDC that I'm focusing on is trenbolone, an anabolic steroid. Anabolic means that it acts like testosterone in the body. Although trenbolone is an illicit drug for human use, it is commonly administered to cattle as a growth enhancer. Over 90% of beef cattle raised in the US receive at least one growth implant, usually in their ear. The vast majority of these implants contain trenbolone acetate, which is excreted into the environment in the form of two metabolites, 17-alpha trenbolone and 17-beta. The widespread use of these growth implants, their high excretion rates, and the potential for runoff has resulted in endocrine disruption in fish located near concentrated animal feeding operations, or CAFOs. You've probably heard the term intersex before. Because trenbolone is an anabolic steroid, it causes masculinization of female fish, or intersex, which can severely impact fish populations. Further research has shown that trenbolone is extremely potent in fish, impacting reproduction at parts per trillion concentrations in water. This is where my research comes in. How can we clean these masculine waters? The solution I'm working with is oxidation remediation techniques. Oxidation and reduction reactions involve the transfer of electrons between chemical species. The overall goal of oxidation remediation is to degrade the harmful contaminant into something less harmful, such as carbon dioxide. I've had the most success with a combination of persulfate and iron to degrade trenbolone in water in a laboratory setting. Thus, when you combine persulfate and iron, you get the persulfate radical, which degrades trenbolone. Thus, these two could be combined in the field to remediate the problem. Although my research is far from complete, I'm so happy with how far I've come over the last 4 years. I began my undergrad career researching fish behavior, and now I'm working with remediation techniques I knew nothing about before. I can't wait to get out there and clean some water. Thank you. Thank you.